Okay, this is the last day of natural logarithmic differentiation. Today what we're going to do is we're going to talk about using logarithmic differentiation to find dy over dx. And really all that means is that we're going to use that we've talked about as far as ln's to help us be able to find the derivative of this. Because this is massive, we'd have to FOIL in here and simplify and use chain rules and all that kind of stuff. But if we really want to, which it will be beneficial to us, we can use logarithmic differentiation, which means we would ln both sides. Now what that does for me is it allows me to be able to use the rules of natural logs, which says, first of all, if we have something raised to this power over here, we can bring that out front. So what I really have is 1/2 ln of x squared times x plus 1 times x plus 2. Then what I can do is now say I have d ln of y is equal to 1/2 times, we can break each of these up because these are all multiplied together. So I'd have ln of x squared plus the ln of x plus 1 plus the ln of x plus 2. This is going to make things a lot easier to find the derivative of. This is kind of in my way right now, so I'm going to bring this to the other side just for a little while. So I have 2 ln y equals, I'm going to end up bringing this out front. So I've got 2 ln x plus ln x plus 1 plus the ln of x plus 2. All I've done so far is simplify this using natural logs. I haven't even taken the derivative yet, so now I'm going to be starting to take the derivative. So this would be 2 times 1 over y equals, and I left off my dy over dx accidentally. This is taking the derivative with respect to x, so I need to put a dy over dx. This is equal to 2, and then this would be times 1 over x, plus the derivative here is 1 over x plus 1, plus the derivative here is 1 over x plus 2. So now what I really have is I have 2 over y dy over dx is equal to 2 over x plus 1 over x plus 1 plus 1 over x plus 2. This isn't simplified or solved for dy over dx. What I have to do is actually move this 2y to the other side. So I'll multiply by the reciprocal, and now I'll say I have y over 2 times this whole bit here. Now, if I really wanted to, I could make a common denominator, and a lot of times, the back of the book, that's the way they're going to simplify this. So don't feel like you need to make your answer exactly look like whatever their answer is. And they're just making common denominator. But one of the things you do need to do is you do need to substitute back in for y. So our dy over dx, and I'm going to try to squeeze this in on the screen. The y is this whole part right here. So I have the square root of x squared times x plus 1 times x plus 2 all over 2 times, it'd be 2 over x plus 1 over x plus 1 plus 1 over x plus 2. So that would be my final solution right here. This last example, what I'm going to be doing is I'm going to use logarithmic differentiation again. The reason why I want to do that again is because this would require a quotient rule, and the quotient rule will have product rule inside of it. And what I can do is totally eliminate all that by using the natural log. So I'm going to natural log both sides. And what that allows me to do is use the rules of natural logs to simplify this before I take the derivative. So the rule I'm going to be using in this case happens to be that I can separate these by subtraction. Then what I now have is I can separate the x plus 1 and the x minus 2 by addition. I have to be careful here when I go to do the second one. This is minus this whole bit. So I actually need to make sure that I'm subtracting this ln of x minus 1. And I either need to keep these parentheses here, so I've got plus the ln of x plus 2, or I need to go ahead and distribute that negative through right now. I'll just go ahead and leave it like that for right now. I will take the derivative of this. So I have 1 over y dy over dx is equal to the ln of, and I take this derivative, I get 1 over x plus 1 plus, I get 1 over x minus 2 minus, the derivative here would be 1 over x minus 1 plus, the derivative is 1 over x plus 2. The only thing really left to do is to distribute this negative through and multiply both sides by y. So I end up with y times 1 over x plus 1 plus 1 over x minus 2 minus 1 over x minus 1 minus 1 over x plus 2. We should substitute back in for y, what y is equal to, which is this whole amount. So I have x plus 1 times x minus 2 all over x minus 1 times x plus 2 all times 1 over x plus 1 plus 1 over x minus 2 minus 1 over x minus 1 minus 1 over x plus 2. And that would be my final solution there in the blue.